Before there was anything, 4.5 billion years ago, there was nothing here. Not emptiness. Emptiness is too simple a word. There was a cloud. A vast, cold, slow-spinning cloud of gas and dust, drifting through the arm of the Milky Way like fog over a morning field. It had no name. It had no center. It was just there, patient, waiting. Then something disturbed it. Perhaps it was the shockwave of a dying star nearby, a supernova, one of the universe's most violent explosions, sending ripples through space like a stone dropped in still water. Whatever it was, the cloud began to collapse inward, slowly at first, then faster. Gravity is patient but relentless, and once it gets hold of something, it does not let go. The cloud began to spin. As it collapsed, it spun faster, the same way a figure skater pulls in their arms and accelerates into a blow. The center grew hotter, denser. The pressure became extraordinary. And then, at the very heart of the collapsing cloud, something ignited. The sun was born. The key. Let's be honest about something. This is not a story about 8 planets orbiting a star. This is a story about a star and the small, scattered family it gathered around itself. The sun owns this system, completely, utterly, without question. It contains 99.86% of all matter in the solar system. Everything else, every planet, every moon, every comet, every asteroid, every grain of dust drifting between worlds, all of it together makes up less than 1/4 of 1% of what exists here. The sun is not the center of the solar system the way a teacher is the center of a classroom. It is the center the way an ocean is the center of a drop of water floating on its surface. And yet, what a star! The sun is a nuclear furnace 1.4 million kilometers across. Every second, it converts 600 million tons of hydrogen into helium through nuclear fusion. A process so violent, so energetic, that the light produced in its core takes 100,000 years to find its way to the surface. Yes, you read that correctly. The light warming your face on a summer afternoon began its journey inside the sun before our ancestors had discovered fire. The sun is also moody. It has storms, sunspots and solar flares that can release more energy in a few minutes than humanity has produced in all of recorded history combined. It breathes out a constant stream of charged particles called the solar wind, which flows at 400 kilometers per second and stretches all the way to the edge of the solar system and beyond. But mostly, it burns. Quietly, steadily, endlessly. It has been doing this for 4.6 billion years. It will continue for another 5 billion. And when it finally runs out of fuel, it will swell into a red giant, swallowing Mercury and Venus, scorching the Earth, and then collapse into a dim, cooling ember called a white dwarf, smaller than our planet but heavier than a mountain range. For now, though, it burns, and around it, the family gathers. The scorched worlds. Mercury is the closest, and it is also the most misunderstood. People assume Mercury is the hottest planet because it is nearest the sun. It is not. Mercury has almost no atmosphere, no blanket of air to trap heat, no clouds to hold warmth after sunset. So during the day, its surface reaches 430 degrees Celsius, and at night, it plunges to minus 180. Mercury lives in extremes. It has no seasons, no weather, no wind. Its surface is a battered wasteland of craters, some of which have not seen sunlight in billions of years. In the deepest craters near its poles, where sunlight never reaches, scientists have found ice. Actual water ice. On the planet closest to the sun. The universe never stops surprising you. Mercury also has a secret. It is shrinking. As its iron core cools and contracts, the surface wrinkles and buckles, creating enormous cliffs called groups, some over a kilometer high and hundreds of kilometers long. Mercury is literally folding in on itself, slowly, over millions of years. Venus is next, and Venus is a monster dressed as a beauty. From Earth, Venus is the brightest object in the night sky after the moon. Ancient civilizations thought it was two different stars, one that appeared at dawn, one at dusk. They called it the morning star and the evening star. They wrote poems about it. They named it after the goddess of love. They had no idea what they were worshipping. Venus is hell. Its atmosphere is 96% carbon dioxide, a runaway greenhouse effect so severe that the surface temperature is 465 degrees Celsius. Not just during the day, not just at the equator, everywhere, all the time, day and night, pole to pole, the temperature barely changes. It is hot enough to melt lead, hot enough to incinerate the landers that several Soviet spacecraft gently placed on its surface. Most survived less than 2 hours before being crushed and cooked. The atmospheric pressure on Venus is 90 times that of Earth. Standing on Venus would feel like being 900 meters underwater. And then there is the rain. Venus rains sulfuric acid. The clouds that make it look so beautiful from space. Those thick, creamy white swirls, they are sulfuric acid droplets. They fall as rain but evaporate before reaching ground, because even the acid cannot survive the heat near the surface. And yet, impossibly, Venus rotates so slowly that a single day on Venus is longer than a year on Venus. It spins backwards compared to most planets, and no one is entirely sure why. Act 3. The Miracle. After the scorched wastelands of Mercury and Venus, you arrive at Earth, and you stop, because Earth is not normal. Earth is not what you should expect to find in a solar system. Earth is an accident. A perfect, impossible, beautiful accident that has produced something the universe may never have seen before or since. Life. Earth sits in what astronomers call the habitable zone, the narrow band around a star where liquid water can exist on a planet's surface. Not too hot, not too cold, but being in the habitable zone is not enough. Mars is also in the habitable zone. Mars is dead. What makes Earth special is everything else. Earth has a magnetic field, generated by a churning ocean of liquid iron in its core, that shields the surface from the solar wind's deadly radiation. slow grinding and shifting of continental plates, which recycles carbon from the atmosphere into rock and back again, acting as a planetary thermostat that has kept temperatures stable enough for life for billions of years. Earth has the Moon, a companion so large relative to its planet that some astronomers call them a double planet system. The Moon stabilizes Earth's axial tilt, preventing wild swings in climate that might have made complex life impossible. And Earth has water, enormous, world-covering oceans of liquid water, the universal solvent, the molecule that made chemistry come alive. Every single one of these things, the magnetic field, the plate tectonics, the Moon, the water, is the result of specific, random collisions and accidents in the early solar system. Change any one of them, and there might be no story to tell. We are, in every sense of the word, lucky. Act 4, The Warrior and the Giant. Mars carries a story of tragedy. 4 billion years ago, Mars was warm. It had a thick atmosphere. It had rivers, actual rivers, carved into rock, and lakes, and possibly oceans. There is evidence of all of this. Dry river valleys, ancient shorelines, minerals that only form in the presence of water. Mars was alive, or at least it could have been. Then its magnetic field died. Without the magnetic field, the solar wind tore the atmosphere away, molecule by molecule, over hundreds of millions of years. The rivers dried. The oceans evaporated. The temperature plummeted. And Mars became the cold, rust-colored desert we see today. If there is ever life on Mars, and we do not know yet, though research, it died slowly, retreating deeper and deeper underground, chasing the last traces of liquid water. Perhaps it is still there, somewhere far below the surface. Bacteria in deep rock, surviving on nothing, waiting. Perhaps, beyond Mars, there is a region of space filled with millions of rocky bodies. The asteroid belt, the found remains of a planet that never formed because Jupiter's gravity kept disrupting the assembly. And speaking of Jupiter, Jupiter is where the story changes scale entirely. Jupiter is not a planet in the way you might imagine a planet. Jupiter is a statement. It is so large that 1,300 Earths would fit inside it. Its great red spot, a storm that has been raging continuously for at least 350 years, is wider than our entire planet. Jupiter has 95 known moons. 95. One of them, Io, is the most volcanically active body in the solar system, covered in hundreds of constantly erupting volcanoes, its surface repaved with lava so frequently that it has no craters at all. Another, Europa, hides beneath its icy surface a liquid water ocean, warmed by tidal forces from Jupiter's immense gravity, that may contain more water than all of Earth's oceans combined. Scientists believe Europa may be the most likely place in our solar system, other than Earth, to harbor life. Not on the surface, which is bombarded by radiation, but deep below, in the dark, warm water, near hydrothermal vents on the ocean floor. We are planning to send a probe there. Perhaps within our lifetimes, we will know. The Ringed Wonder and the Ice Giants. No image prepared you for Saturn. You have seen photographs. You know it has rings, but photographs do not capture it. The sheer, inexplicable elegance of a planet wearing rings the way a dancer wears a dress. Rings of ice and rock, ranging in size from tiny grains to boulders as big as houses. They are only about 10 meters thick in places, 10 meters for rings 280,000 kilometers wide. If Saturn's rings were scaled to the thickness of a sheet of paper, they would be wider than a football field. Saturn is also the least dense planet in the solar system. It is so light, so full of hydrogen, that it would float on water if you could find a bathtub large enough. Saturn's moon Titan is perhaps the strangest world in the solar system. It is larger than Mercury. It has a thick nitrogen atmosphere, the only moon in the solar system with a substantial atmosphere. It has clouds, rain, rivers, and lakes, but not of water. Titan is far too cold for liquid water. Instead, Titan rains liquid methane. Its rivers are methane. Its lakes, dark, still, and icy cold, are filled with liquid methane and ethane. It is a world that looks almost familiar and is completely alien. Uranus rolls through space on its side, tilted 98 degrees, so that its poles face the sun directly. No one is certain why. The most likely explanation is that, long ago, something enormous slammed into Uranus and knocked it sideways. Whatever hit, it was probably the size of Earth. Uranus is also the coldest planet in the solar system, colder even than Neptune, which is twice as far from the Sun. Uranus seems to emit almost no internal heat, and scientists are still not entirely sure why. Neptune is the last of the 8, dark blue and impossibly far away, so far that sunlight takes 4 hours to reach it. Yet Neptune is violently alive. It has the strongest winds in the solar system, supersonic winds, moving at 2,100 kilometers per hour, which create enormous dark storms that appear and disappear within years. Neptune was discovered not by accident but by mathematics. Astronomers noticed that Uranus was not quite moving the way it should, as if something was pulling on it. They did the calculations. They pointed a telescope at the predicted location. And there was Neptune, discovered by the power of human thought alone, before anyone had ever seen it. That moment, in 1846, is one of the most beautiful in the history of science. The edge of everything. Beyond Neptune, the solar system does not end. It fades. There is a vast region called the Kuiper Belt, filled with icy worlds and frozen objects. Pluto lives here, demoted from planet to dwarf planet in 2006, to the outrage of many, but revealed by the New Horizons spacecraft in 2015 to be extraordinary. Mountains of water ice, plains of frozen nitrogen, and a heart. Literally a heart-shaped plane that has become the most beloved image of our outer solar system. Beyond the Kuiper Belt is the Oort cloud, a vast, spherical shell of icy bodies extending perhaps a quarter of the way to the nearest star. When a comet falls inward toward the sun, trailing its ghostly tail of ice and gas, it has often begun its journey in this distant, dark, barely imagined region. The solar system extends, in some sense, all the way to where the sun's gravity ends, where it finally gives way to the gravity of other stars. That boundary, the heliopause, was crossed in 2012 by Voyager 1, a spacecraft launched in 1977 carrying a golden record with sounds and images of Earth, intended for anyone, anything that might ever find it. Voyager 1 is now the most distant human-made object in history. It is over 23 billion kilometers away. And it is still moving, still sending data, still alive, powered by radioactive decay, guided by human hands across unimaginable distance. A small, golden message in a bottle, floating in an unimaginably large sea. Final words. The solar system is not just a collection of rocks and gas orbiting a fire. It is a family, ancient, violent, tender in its own strange way. It is a story of catastrophes that became miracles, of near misses that became worlds, of dead planets and living ones, of ice and fire on the thin blue line of air that separates existence from oblivion. It is our home, and we have barely begun to explore it.